Okay, today I'm going to be performing a most peculiar and most interesting experiment. So I have almost everything I need for this experiment set up on the table. By the way, before I begin this experiment, I have something else I think y'all might find interesting. So I noticed in one of my previous videos that y'all were interested in a coat I had from 1904. Well, this coat I am wearing currently is from 1900, so it's 123 years old. I need to do some work on this, but it wasn't like that when I got it. I've worn this almost every day that I worked at the hotel. When I worked at the hotel, I worked there for about 2 years, and I wore this almost every day. And it held up very well. But the date that this coat was made is on this inside pocket. It's right here on this tag. Here, I'll zoom in. Here is the tag. Notice this coat was made 6/16 of 1900. Also, I don't believe the coat was worn very much because inside that pocket as well there is an extra button. So I always have people ask me where can they get coats that are authentically old like this 123-year-old coat. Well, if you go to Etsy, that's the best place to look for them. You can get them for the best bargain there. Facebook Marketplace is a good place. eBay is a good place. Those are my three go-to places. And my oldest coat I have was owned by a lawyer, and it's from 1895. And it's in good condition too. They made things simple and they made them to last. I'm sure y'all are wanting me to get on with this experiment, so let me plug in the oscilloscope and let us begin. Okay, for the experiment I'm about to perform, I'm going to rewind this coil. Usually when I do this specific experiment, the thicker the wire on the extra coil, the better. I'll be using number 20 magnet wire. Okay, let us rewind this coil now. So my guess is after this is all wound up, this should resonate between 4 and 8 megahertz. And I have begun winding the coil. The cleaner the turns are, the better this will work. And I have spaced the top turns. Okay, I have finished winding the coil. This coil is in no way ideal. You can see where the turns overlap a little bit. So in my previous videos, you'll know that I sent electricity 918.6 miles wirelessly to Chicago. I used a thing called a magnifying transmitter. If you watch my previous videos, you'll know what I'm talking about. Well, that thing sends electricity through the earth. It's basically like a wired-in radio system. So you have the transmitting station, or the broadcast station, and the receiver, which is, the receiver's like a radio, and the magnifying transmitter is like the one broadcast station that the whole world needs. And it's tuned to a harmonic of Earth's natural frequency. So anyway, my point is, this thing behaves like the extra coil, or that third coil in the center of the magnifying transmitter. Now I'm going to tune this coil and you can observe some interesting effects. So while I set up this oscilloscope to tune this coil, I'll tell you, I googled Dr. Parkenstein, I googled that and I noticed that on Reddit, some people are talking behind my back saying they don't think that I sent electricity wirelessly 918.6 miles. I have video proof and I've explained how I did it. And they say like all of my followers are gullible and they're sheep and everything. I have no reason to lie to y'all. I'm just trying to better the earth. Anyway, make the world a better place. But anyway, so this will kind of clear up things as well. So I'm going to be inputting a 19-volt signal into this little coil right here, and you'll see some very interesting effects with just 19 volts. This thing is powered by 5 volts. It plugs in right over there on that little thing. Here, let me turn on my flash. On that, and then that comes up to here. Oh my god, I almost dropped my phone. But you can see the input is 5 volts DC. Okay, let's tune this. So in every scientific work, when the idea is introduced, it will be ridiculed until it is accepted as evident. And that's basically what's happening now. Anyway, okay. Okay, so to tune this coil, we'll want all metal objects away from it because that'll add stray capacitance and kind of mess up our tuning. Okay, so we need a capacitance to attach to our oscilloscope probes, or one of these probes. I'm actually going to use this fork. Now I get to call this a tuning fork. So I've just set the tuning fork on my top hat. It's in proximity to the coil. Now I will connect the bottom of this coil to the signal generator, and I will dial up the frequency until we get the biggest waveform on our oscilloscope. Okay, I had to push the auto setup button on our oscilloscope to get the waveform to freeze and be static like that and not keep moving. Now I'm going to turn on the signal generator, which, by the way, I've connected the red lead to the bottom of this coil. The black lead is free. You can follow the wire into the signal generator, and you can follow that wire. Okay, here we go. And see, that's going to stay the same, exactly like that. Okay, let's turn this on. We'll start with a 20-volt signal. See, it adjusts the wave already. Now we're actually going to tune it to a frequency. I would say it's about 4 to 8 megahertz. That's a big... Let's dial down the voltage a little bit so that we can see the whole wave. Okay, up again. Up. Okay, it's somewhere between... Okay, it's around 2 megacycles. Okay, let's adjust this so that we can see the whole wave again. Oops, I bumped that. Okay. Okay, we want to adjust this for the biggest waveform on there. Okay, now I'm going to dial into the finer adjustment. I moved from that 2 to this 1 digit. Okay, that's settled. Let's dial this down again. Okay, now I'm going to move to the next digit. Okay. Wait, I just disconnected it again. Why is this... Okay. Come on. Okay, this isn't making a good connection. Okay, I believe we've got the tuning dialed in. There is one way to check this, however. Let's try this. So I'm going to come over here and take this. Let's pull it out of there. Perfect. Well, let's touch this to there. Sorry, it wasn't making a good connection. I actually took a knife to this end and took off the insulation. Let's touch it now. Look at that. You see that light? Look at that. See the lines flowing through it? That is 19 volts. Let me come over here and turn off. Here, let me show you all this first. So there is our actually 20 volt signal coming out of this signal generator, going down through this into this coil. There's the top of the coil. It's free. Nothing else connects. Here's our tuning fork. Let's move all this from the tuning of this, and we'll just have this. Now let's turn off the light and come over here with this light bulb or fluorescent and touch the top again. There it is. That is 19 volts. Let me touch it. I'm touching it now. See? See, I'm touching the top of this, but if I put the bulb on there, we get light. See the lines flowing through there? Let me turn off the flash again. Anyway, I thought y'all might think that was interesting. So I was about to stop filming, but I noticed something else most peculiar. So I took the light bulb and I held it like this, and you can see the lines of alternating current. AC gets the name alternating current because it literally goes back and forth in the wire. Look at those waves going up right there. You can barely see it, and the waves going down right there. And if I move it to the exact point, it gets brighter.